Hello, everyone. I'm Kathy Mira here from Erwin Inc., and I'm pleased to introduce today's session, DM07, Data Modeling in an Agile World. Our speaker today is Jeff Harris, a longtime friend of Erwin, currently with Myriad Solutions. Jeff, thank you so much for joining us here at Erwin Insights.
Good day, thanks Kathy, and good day to everybody attending the session.
Why don't I just get out of the way and turn the session over to you to begin.
Okay, perfect. Thanks, Kathy. So yes, our session is data modeling in the Agile world. You know, one of the questions I've often been asked is, how do you manage data modeling when your organization is moving to an Agile development methodology? And it is always quite a challenging feat to be able to get your head around how to be able to deal with it, and what's the best way to work, and what techniques will actually make you successful. And one of the key points that I always point out, you know, if you follow the right techniques, you'll be successful at it, but if you fail at it, you're going to fail dismally. So I'm going to be presenting today a little bit about how you can actually work in an Agile world, keeping all of your basic data modeling principles in place, but being able to adjust to be able to handle how the development is being done in an Agile methodology. Just to give you a quick introduction to the agenda we're going to be following today, we're going to start off with a quick introduction about understanding how the waterfall software development process works. Then we'll be going into the Agile software development. We'll be comparing a little bit about how the two operate against each other, so waterfall versus Agile. We'll also have some of the values that we will see from an Agile software development methodology. Then we will drill down to the specifics of how we did data modeling in a waterfall approach. And then we will be drilling into how we're going to do it in an Agile world. What are the differences between the two? Then we will look at some of the challenges you're going to experience from a data modeling perspective when you've got an organization that has changed to an Agile methodology. We then will look at Erwin Data Modeler. How does that help us to be able to achieve your goals in an Agile world? And I will take you through a walkthrough of how you will actually manage your models, how it will be handled, and what's the best way of dealing with an Agile modeling methodology in Erwin Data Modeler. We'll be closing off with a Q&A at the end. So if you've got any questions, please type them in, and I'll answer them at the end of the session. So just quickly to recap a little bit, who am I? I'm the Vice President of Professional Services for Myriad Solutions. I'm also the author of the Data Modeling Made Simple with Erwin Data Modeler book. Prior to that, I was the Principal Data Architect for a Fortune 200 company, and I have in excess of 30 years of IT experience and in excess of 20 years data modeling and data architecture experience. My experience has led me to implementations of data warehouses, ODSs, enterprise data architectures, you name it. When I dealt with data, I've pretty much gone full end-to-end as far as data architecture is concerned. And due to this knowledge that I've gained over the years, I've been asked to present and publish articles on data-related topics over the period of time. So just quickly recapping a little bit about the Erwin side of it. I've been a data modeler, and one of my preferred tools has always been the Erwin Data Modeler tool set. And I've worked with it from version 3.5 right up to the latest versions. And I've been involved in beta testing, you name it, I've been involved with it. And I bring a whole lot of my best practices and my knowledge And that's what I bring to you as a client. While I'm on the topic of talking a little bit about myself, I also wanted to just quickly introduce the book that I wrote. I co-authored it with Steve Hoberman, and it's a hands-on approach that will take typically a business analyst, a data professional, project manager, and be able to step them through the process of effectively building a conceptual, logical, physical data model. It'll give you the foundations of data modeling, right through to how you do it in the Erwin Data Modeler tool. This book can be purchased. It's available through Kindle, Google, eBooks, Amazon, and PDF formats. If you go to the link that I've shown on the screen, techniquespub.com/ErwinDM, you can purchase the book in the various formats. And if you use a coupon code of ErwinDM, you can take 20% off of the versions that you can purchase through the website. So if you're interested, please use that coupon code to be able to purchase the book. So that's enough about me. Let me start talking about the waterfall software development approach. Now, one of the things about software development, it borrowed a lot of the processes and procedures that were inherently used in the real world from a mechanical engineering perspective, from a construction perspective, and waterfall is a traditional methodology that was used in most of these industries. So you think about it from a perspective of the mechanical engineering process. You would typically be able to design something, you will then go through a build, a test, and then you'll actually have a finished product. So it is a very sequential process. You don't work or think in an agile methodology when doing a mechanical engineering route. So traditionally, software development followed a very similar route. So it was very well founded in a sequential methodology. And the benefits it brought was it was very predictive. So waterfall lends itself well to a large project where you need to be able to estimate how long, how much. All the predictions can be easily derived through a waterfall approach. It has a defined end point and has a set deliverable. It's also well geared up when you're looking for a complete solution. So you take it like a typical application where you want to actually deliver a complete built solution for a particular business user. When working with large banks or government services and sectors, they like to have a complete solution that is working, and they're not really interested in a work in progress solution. So that's really where waterfall came in well. Another aspect behind a waterfall development approach is quality. You know, waterfall focuses on quality because it has the predictability. You have a set of deliverables, you have a set expectation of a time frame, and you expect it to be at a certain quality standard, where we like to be able to look at it and say, well, we know how long the load times would be. We know how much the use rates are going to be, the traffic, the vulnerability, proofing, and compliance. All these things add to the quality of the build and the predictability of the solution. So waterfall was a traditional way that we worked. But in came a new concept called Agile software development. Agile approaches development requirements and solutions through a collaborative effort of self-organizing and cross-functional teams. It advocates an adaptive planning and an evolutionary development process. So it gives an early delivery and continual improvement. And it also encourages flexible response to change. One of the things about Agile development was polarized by the Manifesto for Agile Software Development. The values and principles is espouses in this manifesto were delivered from and underpin a broad range of software development frameworks, which include Scrum and Kanban. The typical Agile methodology is you define, you build, and you release, and then you repeat the whole cycle over and over. And you're slowly building and adding to it. It works in small chunks of building and releasing so that it's well built in to be able to find and improve and quantify the actual expectation out of the client. So one of the points I did want to make at this point as well is, as much as we're going to be talking about Agile development, I'm not going to go to the specifics of which framework you're using, whether it's Scrum or Kanban or whichever methodologies you want to use. I'm talking generic Agile software development, which is adapted to whichever means you want to be able to deliver using Scrum or Kanban, or what other frameworks you use. So let's just have a look at some of the values that we get out of Agile software development. It focuses on individuals and interactions and doesn't specifically push towards tools or processes, even though tools and processes are very important. But it's more important to have a competent set of people working effectively together. So one of the key aspects of Agile is really to be able to drive that people are communicating, working together, being able to find the solutions that they need. It also focuses on working software over comprehensive documentation. Now, this has always been one of the burning points of a waterfall development team, that Agile doesn't deliver documentation. Good documentation is useful and in helping people to understand how the software was built and how to use it. But the main point about development is creating software, not documentation. Doesn't mean that Agile doesn't cover documentation, but you cover documentation in an Agile method as well. So you slowly build on your documentation, and that's really where data modeling comes in as well, because data modeling is really part of your documentation side. And through that, it actually gives you that documents from your data model. Another important aspect that Agile software development provides is customer collaboration. It's important to bear in mind that when you're dealing with a customer, we're inclined to fall back to the concept of actually having a contract in place and negotiating what the deliverables are. But Agile says we need to be more in tune with what the customer actually needs, more than about the contract. The contract is important, but it is not a substitute for working closely with the customer to discover what they really need. So by working closely with the customer, you get more what they are expecting of the software and less about just worrying about the actual contract in place. I mean, a good example of this is, I'm sure we've all at some stage, especially in our younger years, played the game where you actually draw something on somebody's back. So you take it that one person draws a particular object and they draw it on the next person's back and the next person and so forth. And through this process, you eventually get something that's totally different to what was actually planned in the beginning. Taking this simple scenario, your business is actually asking you to develop a snowman. So they draw on your business analyst's back a snowman. And by doing this, they draw the first circle of the snowman, and the business analyst draws a circle, and eventually goes down where the actual developer draws the circle. Then you go and draw the second circle for the next part of the snowman, and it eventually winds its way down to the software developer, who draws a second circle on his diagram. And at the end of the day, with all the bits and pieces put on the snowman, the business user that's actually doing the definition of the requirements has drawn his snowman. But in the meantime, that the actual developer has actually drawn a fish. So that's a typical example of how we do software development in a waterfall approach. We design things based on what we think the requirement is and from what we interpret with it. And by the time we actually get to the end product, we're sitting with a fish when the business was expecting a snowman. If the business had an agile software development approach, they would draw the circle and validate the circle that the software developer drew. Then the second circle would have come down and said, wait a minute, that circle's not in the right place. It's not an eye on the fish. It's actually on top of the fish's body, and it's actually not going to look like a fish anymore. So you can understand how the collaboration with the customer is very important. And this is one of the things that Agile software development leverages. Another important aspect is responding to change. This is trumped over following a strict plan. A project plan is important, don't underestimate it, but it is not, but it must not be too rigid to accommodate the changes in the technology, the environment, the priorities of the stakeholders, and the people's understanding of the problem or its solution. So very much as my synergy that I used with the snowman being drawn, the respond to change. So when the developer actually goes back with the first set of drawings, which is the delivered product in a development process, the business user would be explaining, no, that's not what I'm looking for. And there would be a correction put in place to be able to align it in an early stage before it got down too late. So through that, I'm going to go through a quick understanding, quick comparison between the different two processes, how a waterfall process versus a agile process works. Traditionally, a waterfall process, we gather our requirements. That feeds into the design phase. And once we've finished with the design, we go into a development phase. And from development into testing, and then we deploy our solution. Notice that there is no loop back to the requirements. So we are assuming that the previous phase is complete and that everybody's happy with it. But if the business does not understand what we actually defining in the previous phase, that gets carried forward. Where Agile is about defining our requirements in a loose framework, then we start planning what we're going to actually develop. We then develop it. We go through testing. And if it is at a mature enough level that it has business value to be able to deploy, we then deploy it. If not, we go back into the review and go back to planning with it. If we have deployed, we still go back to review. So in other words, we review, is this what the business was expecting? And if it's not, we push it back into planning. If it is, what's the next set of requirements we need to build on it? So it's a very recursive process. And we keep on repeating this process over and over, developing and building on and evolving the solution over the time. So that's how software development is handled in an agile software development process. Now let's start looking at it from a data modeling perspective. So from a waterfall data modeling perspective, we follow a sequential design process. So traditionally, we'll start off with our business requirements gathering. So we will actually sit down with our business users and get an understanding of exactly what they're looking for, getting a rough understanding, expanding it out, and really getting to understand all the requirements. So through that, we will then go through to a conceptual data modeling phase, where we'll actually take that information, those business requirements, and translate that into key business objects. These are the objects that are important to the business. We'll then highlight which are those and how they all relate to each other. So in other words, building the fundamental business rules. So how does a product relate to a customer, to an order, etc., etc.? So through that, we'll be defining our conceptual data model. Bearing in mind, we do not go down to properties. We're just putting those high-level key business objects into scope and understanding how they relate to each other. We then will take it to a logical data model level, where we will take that same conceptual data model and expand all the key business objects and make them into entities. We will start filling those key business objects with properties, which then become the attributes. We'd start refining the business rules or the relationships so that we can be sure that we're building out the correct type of relationships between these objects. So we're interpreting how the business sees these objects all working together. And that forms the basis of our logical data model. Once we're happy with our logical data model, we then go to the physical data model, where we'll actually take that same logical data model and progress it to a physical data model. And we will start adding things that are physical implementation requirements. And the requirements that hold no business value, but are requirements that are required for the database or the data structures. A good example of this is when we design a logical model, we might have designed some many-to-many relationships. And when we come to the physical model, many-to-many is not allowed in a database, or it's not an effective way of being able to implement in a database. So we create a many-to-many interim table, which has really got no business value, but it's actually a database-specific requirement. So we'll be adding those type of things. Others are things like indexes. We'll work with indexes, add indexes, and really refine our data model to the point where it is implementable in a database. Final step is we'll generate a DDL script that will be used to be able to generate the database in the, generate the schema in the database for us. So it's a manifestation of all of the work up to this point is actually transgressed into the DDL script. So that's a typical waterfall modeling methodology. Yes, it does you do work with an iterative approach, but those are different phases. So waterfall does have phases to it. So you might have a phase 1, phase 2, or phase 3 of a project. But generally speaking, you will have it is sequential by its own nature. So taking that one step back into the Agile world, so let's start exploring how data modeling works in an Agile development environment. So first off, and it's one of the points I often look at, is we need to understand that Agile data modeling is an evolutionary data model practice. So we're evolving our data model over time. So each iteration of our Agile process is evolving our data model one step further to being able to comply to all of the requirements that we're targeting. So it is iterative and it's in an incremental manner that we operate. Another aspect that's very important to understand is a domain-driven design approach. Now, with domain-driven design approach, it's one of the methods that are adopted by an Agile software development, and we need to adopt the same thought or the same methodology or approach within our data modeling. And it is by taking targeted smaller domains and not focusing on the entire solution. And it makes it easier for us to deliver each work stream or sprint that we're working within our environment. So one of the key points I like to put out there is Agile data modelers need to travel light and create data models which are just barely good enough, because we're going to evolve it over the time. So we start off with a very straw, simple concept, and as we're expanding it, we expand out our model and growing it. one of the other points is it's also important to ask yourself, when is enough data modeling enough? So you need to get it out fast for the development so they can start telling you what they don't want or how they want it changed. So it's a very iterative process, even within the work streams or sprints. And another important fact that you need to bear in mind is Agile developers like to think about solving today's problem today. And they trust that they can solve tomorrow's problem tomorrow. So they don't try and focus on tomorrow. They only focus on what's happening today. So really, that's an important aspect to bear in mind about how they drive the domain-driven design. Now, let's take a good example. Let's start understanding what this domain-driven design really means. With a development cycle, they look at things like classes, understanding the name of the class, the methods, and the variables of the classes. And that's how they break it down into small domains. So there might be one or two classes involved in a particular domain, and which is incorporated in their particular sprint. Now, take as an example might be like a credit application process. So let's say we're working on a credit application domain. We would look at an application class and a customer class, because a customer applies for an application. So they'd start expanding those out, understanding what type of methods are required. So you might have an accept offer method or a withdraw offer method. You'll have a whole lot of variables that you need to work with. And the variables is often what we need to latch on to from a data modeling perspective. Because whenever we got variables in a method, they need to be reduced to a database, and we need to be able to design for those methods. But by focusing on the bigger picture of the classes, we get an understanding what our key entities are. So by working in small domains, we can understand that the development is going to focus on a specific domain, which is your application domain. And then they will break it down into key objects within that, which are the classes, which may equate to our particular entities. And then we actually look at the methods, is what type of operations they can do on that particular data. And the variables actually translate to our attributes. So we're working through this method of being able to align ourselves with the methodology of understanding how they want to develop the solution. So taking a step back from that, and we understand the concepts of data modeling. So let's go back to the principles of the layers of data models. So you've got a conceptual, logical, physical. When we look at the conceptual model, now we're not trying to design all of the systems, how it's all going to tie together. We're going to look at how we can design how those domains all tie together. So we'll start off with a domain as a conceptual understanding. We then can explode that out to the various different key business objects. So we see customer and application or credit application. So those become our key concepts in our conceptual model. And as we then go down to our logical model, we start adding to that. So we might understand customer might need to expand out further and might have telephone number, whatever. So you expand out of that in your logical model like you would have done in a waterfall, but in a very small focused aspect. And then you would have your physical model. One of the other key aspects is it's a parallel process. I always like to see your conceptual, your logical, and your physical data model are always being worked in parallel. So you focus on the requirements of the work stream or the sprint in parallel to whatever the code requirements are. So the developers are developing their code. They are dictating what type of data they need to store. You are defining how that data is going to be stored within the focus of the domain. We try not to expand it too far out because we don't want to think about tomorrow's problem now. We only want to focus about today's problem today. Another important thing about Agile data modeling, which a lot of people turn around and say, well, Agile data modeling is fast, it's quick, and it's easy, and we don't need to worry about modeling standards. Modeling standards are there. We need to understand how we need to develop an environment for our business that still conforms to the data modeling standards. I mean, our naming standards need to be adopted. We still need to have the same style and guidelines that we use. So we're not breaking away from those concepts. We are still using those basic data modeling standards in our process that we are using, but we're just using it in an agile environment and not a waterfall environment. Moving on from that, it's also important to understand that in an agile data modeling world, we might have multiple iterations. Even within one work stream or sprint, we then incline to have multiple iterations. As I was explaining earlier, as we're evolving our understanding of the requirements, we are then slowly building that into the model. We are delivering to our developers on a fast-paced process what they're looking for. But it may mean that we have to come back several times within the same sprint, adding to it, changing, making it easier for you to be able to understand the requirements by explaining it with what you've delivered. So we must have to understand that it is a multiple iteration process. It's not going to be one model and there we go at the end of the sprint, go, thank you, goodbye type of thing. You work on it, you build on it, and then you deliver to it. Another one is the communication and collaboration. This is fundamental to the agile world. As we pointed out, individuals and interactions is one of the software development values. So by communication, we need to communicate the data model regularly to the developers and collaborate with them when they tell you that's not what they're looking for. Then you need to go back to your drawing board and rethink what they're looking for, how you're going to be able to deliver it in a data model. So through that, you'll have a successful agile data model evolving and growing to what the requirements are. And while we're talking about requirements, it's important to understand the requirements are never static. We must always understand that the requirements are going to be changing. As you define all the requirements over time, it's going to change what our understanding of the model is. So we need to embrace the concept and adopt techniques which allow us to react effectively to our gathering of these requirements and adapting our models effectively. You know, if you try and define all the requirements up front, you're setting up yourself for a failure in your data model. And at the end of the day, either you're going to sit with developers waiting for the data model, or they're going to be sitting there and saying, listen, this is nothing like what we need. You're taking way too long, or it's going to be confusing them. So we need to understand this, that the changes are going to be coming down the line. We need to embrace it and to be able to deal with it. You know, there's a saying that I always like to quote, you know, applications and data stores come and go, but data is always there. Learn to accept that one can always migrate, transform, or manipulate data to suit the business requirement as the data model evolves. So we need to understand that it doesn't matter what we're developing, we need to be able to embrace the new technologies. And today we might be modeling for a relational data model. Tomorrow it might be a NoSQL database, might be big data. Doesn't matter where we store the data. We need to be able to embrace the new technologies and understand we can move data, we can change it, we can manipulate it, and we can get it to what it needs to be. The old traditional way of having a robust data model that quite literally can answer any business requirement well up front is dying. We need to be agile, we need to be fast in being able to change and adapt. I always like to think back to the concepts, and maybe this ages me a little bit, but bear with me. Designing model, data model for the old systems where in the old days, customers only had one telephone number. So generally we would see telephone number as being an attribute for a customer. As time evolved, we got to understand that, well, maybe customers have two telephone numbers. So we said, okay, well, we've got a home and a work telephone number, nothing too much to worry about. Well, today we sit and say people can have multiple telephone numbers. They can have cell phone numbers, mobile numbers. They can have multiple cell phone or mobile numbers. They can have multiple home numbers or work numbers. You name it. We build systems that allow for multiple telephone numbers. So what did we do? We actually said, well, we can't build it into the customer table. It has to be in a telephone number table. And there's a relationship to customer as far as a data model. That's how data evolves over time. Life is not static, it evolves. And we need to be able to evolve with life as well. So hence the reason why Agile has become more popular in a methodology for software development. And we as data modelers need to be Agile too, else we are going to slowly work ourselves out of that situation of losing control of the data structures. Let's have a look at some of the challenges you will experience as an Agile data modeler. I put down, these are three, and I mean, there must probably dozens of others out there. I just thought I'd put down three important ones that I've come across over the time. Often data modelers are not brought into the Agile process until the various developers, Scrum Masters, business analysts are at a stage in which they need some data. So you often see it that you as a data modeler only get to know about the actual process when it's already too late. You're already being put on the back foot and you're having to try and get involved in an Agile development cycle when they're looking for data. So you need to be able to expect that's what's going to happen and find ways of dealing with it. Another one is there are numerous distinctions between the objectives and approaches and the needs of developers and data modelers that provide the various points of conflict. Since the Agile cycle typically begins and ends with the developers, you remember that cycle with the Agile cycle? The developers are always the key ones in focus in an Agile process. So the tendencies can exacerbate the involvement of the data modelers. So they think and they are more important in the process of being able to deliver the solution for the business. So data modelers are often looked at as lower level in the Agile team. They're not seen as being upfront with the business people because they are a byproduct of the development. And it's just one of the challenges you have to deal with. Another one is because we get excluded from the Agile project right up at the beginning stages, often we have to play a catch-up process, which we ideally should work ahead of the sprint, but we are actually working behind the sprint trying to catch up. It's not uncommon that as data modelers, we also need to be able to be agile enough to work in several different sprints or several different Agile teams at the same time. So we need to be nimble and able to adjust to all of the business requirements and to be able to work effectively and catching up at the same time. So we have to work as efficiently as we can. And come back to my original comments earlier, you've got to stay domain focused. That's the only way we can do it. If we try and think further than what the scope of what our particular sprint is or the work stream, we're going to start losing our ground as far as data modeling is concerned. So let's have a look quickly at Agile data modeling in Erwin Data Modeler. So I think this is an important statement I've put out here. Agile data modeling isn't in the tool. Erwin is not an Agile data modeling tool, but then there is no Agile data modeling tool. Agile is in the way we actually use the tool. It's a process and the procedures we put behind the tool that makes it Agile. So Erwin actually can do it for us, but we need to build those processes and procedures to make it Agile. Now, Erwin can provide us with tools or functionality within it that can assist us in our Agile data modeling process. And I've just listed 4 of them. And I mean, obviously, there's a lot of tools in Erwin, and we use a lot of them to create entities, attributes, whatever the case may be, tables, etc. The traditional design layer approaches, all of that is built in the tool, and we will leverage all of those. But these 4 I find very important to the process. The first one is the Erwin Mart Server. Now, traditionally, we need the Mart Server for storing all of our models. Because Agile is a very evolving, fast-paced, we need to be able to manage our versions very effectively. And the different versions and the different work streams and sprints of the models. So we need an environment where it's easy to be able to store them, easy to manage, and easy to be able to retrieve the models, work in a collaborative manner, all of those type of things. And Erwin Mart Server provides that for us. The next functionality is a derived new model. Now, traditionally, when we work in Agile environment, one of the key things is we like to branch off models. We need to branch off models for each of the work streams or sprints and work with them isolated from other model with the base model. And to be able to do that, I like to use the derived new model feature. Now, that's a great way of being able to separate your model out, but yet keeping the ties back to the base model all the time. The next one is sync with model source. Now, the sync with model source we use for merging the work stream or sprint model back into the base model. Now, by doing that, we can then reintroduce into the base model all the changes or designs we put in our sprint or work stream model. So sync with model source is a key aspect. And the last one is complete compare. Now, I cannot talk enough about complete compare as far as a tool is or functionality in Erwin Data Modeler. I think if there's one function in Erwin that I really think is most important for all data modelers to really understand, is complete compare. Complete compare can be used for dozens and dozens of use cases in a data modeling practice. But for this one, we use it for synchronizing the changes in a model when we're resyncing back to the model source. In other words, getting back to our base model, we need to be able to use this to be able to change it across to the other work stream or sprint models. And that's where complete compare really comes in and is really powerful for using within Erwin Data Modeler in an Agile data modeling environment. So I've now spoken about a lot of functions and a lot of features. So I'm going to now go through a walkthrough to understand where we use these functions and features and where we can actually leverage and how we leverage Erwin Data Modeler in an Agile world. We start off with a base model. Now, traditionally, when we start with an Agile data model, let's say we are fortunate enough to start off right at the beginning of our Agile life cycle, and we can start introducing a base model. The base model must have no entities, no attributes in it. But our base model must probably used through templates, incorporating our modeling standards. So that has built in all our modeling standards. Whether it's the domains, whether it's got standard diagrams, whether it's got how the look and feel of the diagrams are, our naming standards, all of that gets built into a base model. But it's an empty model as far as the data model is concerned. because it has no entities or attributes yet. So when we take this base model, we start off, we don't just work on the base model to be able to generate our first work stream or sprint. We then derive a new model out of it. Even though it's empty, we derive our first work stream or sprint. And that we will use to do our development. So we'll take that, we'll apply all our changes to that particular model. And you'll notice that I referred to version 1, version N. You will notice specifically that our base model is still at version 1, but yet our workstream model, we are progressing to version N. So as we're working on it, we are developing it, and we're expanding that model with our requirements for the workstream or the sprint. Even if it means we're building, we're breaking down, rebuilding, whatever in that, remember the iterative process within the sprint, we are working in that model to develop it. And that's where the versions come in very important. You know, one of the things that I look at is Erwin Mart Server provides us the ability to, every time we save the model, it creates a new version of our model. So if we build something and we need to break it down, we can use information from old ones. We can use complete compare to reintroduce things that we might have broken down previously. So we can use it to be able to build our model. Now, through the Agile cycle, if you remember earlier, I sort of explained it's an iterative process, or it repeats itself regularly. Well, another thing about Agile is you may actually have separate work streams starting off in parallel, or you may have work streams or sprints starting that have not starting before the previous one has actually been deployed. So how do we manage those type of things? So one thing, stepping back a little bit about each of the versions, when we actually go through the versions, we can use the deployment process. And generally what we do in each of the work streams, we generate the DDL to be able to deploy into the development environments. So each of these versions we're deploying regularly to the development environment and keeping track of what we want to do. We're totaling down the database, rebuilding it, whatever needed for the development team to be able to interact with it. Coming back to my line of thought, how do we introduce a second work stream? So as the second requirement comes in, or the second iteration or process in our Agile cycle comes in, we can then take off a derived new model out of our base model, not out of our sprint work stream model, a second version of our model. We call it our work stream or sprint 2 model. And likewise, that model then can be evolved and worked on separately to the work stream 1 model. We get to a point where we want to actually deploy our work stream 1 model. First thing we do, and I'm always a fond believer of keeping archived models, so I take a copy of that base model and I copy it to an archive folder, and I then take that workstream 1 model and use the sync with model source to sync those changes back into my base model. Bearing in mind, the sync with model source is really using complete compare, but it's using it behind the scenes because it's actually working. It's a subset of complete compare. It allows us to be able to change those, apply those changes to our base model, creating a version 2 of our base model. So what do we do about our work stream or sprint 2? Well, that's also achieved by being able to go through a process of using complete compare to apply those changes to our workstream 2 model. And by being able to do that, we generate our workstream 2 model in bringing it up to the same as our baseline model, version 2. So by using complete compare, we now are keeping all of our other sprints or work streams in parallel to what has been released into our base model. One of the other important aspects is we will use our baseline model to deploy the DDL for our environment where we go to testing and production. So our base model is a reflection of what we're actually putting into our test environment and then reflective of what we put into production. Now, talking about how you manage the various different environments when you've got test, dev test, and QA, and a production environment, that's a different sort of topic. I don't cover the management of those different models. The important thing to understand is we use a base model that is reflective of where we're deploying to. Moving on from that, we can even introduce a third work stream or sprint model, and that's our work stream sprint 3. We derive it out of the most current version of the base model. And through that, we then can go and derive a new model and then modify it and adapt it as we need to be able to get to a final version for that sprint. As you can see there, roll out of the models, we go through the same sort of process. Whenever we go to a point where we're going to actually roll out a model, like workstream sprint 2, we will use sync with model source to increment or evolve the base model, and we'll apply those same changes using complete compare to any other workstream or sprint models that are open at that point in time. It's also important to understand that when you actually use the sync with model source, you get to understand what's changed. So through this process, you will see the changes that are applied to the base model, and then you use that as input or knowledge for the complete compare to all the other workstream models. So as you can see, it evolves and grows through the process over time. With that, it concludes my presentation, and I would like to hand over to Kathy to take over from here quickly.
Thank you so much, Jeff. I know I, for one, am better for attending this session. I really took away a lot of things I wasn't certain about, so thank you for that. Some questions for you, and those we don't get to, you'll be following up with folks that ask them direct. But how about this one? How would it work if we don't have the Erwin Mart server?
Yeah, you can always recommend using the Erwin Mart server, because as you can see, it manages the versions. But if you're not fortunate enough to have the Erwin Mart server, it is possible to work, but just bear in mind you're losing the collaborative capabilities. You're losing the ability to be able to keep track of the versions properly, and they are file-based models, but you can build the same structure in a file environment to be able to keep your copied models, to have your separate workstream models that you can do. You're just losing the collaborative and the version control.
Okay, thank you. How about this one? Is there one major point of advice you would give to a company starting to work with an Agile methodology?
Yes, I think one of the most important things, if your company is starting to go to an Agile methodology, you need to align yourself to being Agile yourself. One of the key challenges we sit as data modelers, we've got a very inherent way of thinking of, we go through the design, we go through the various or requirements gathering design through all the layers to be able to get to a data model. We need to start thinking Agile ourselves. We need to start thinking that when is enough data modeling enough? We need to start realizing that we're not going to fix tomorrow's problems today. We just focus on today's problems today. So I think, yes, there's a couple of things that we can introduce, and just by keeping that mindset right, being able to be agile. I mean, it's a bit of a cliche in words, but yes, it is agile because it is called agile because it is agile. We need to be nimble, fast in reacting, and capable to deal with whatever gets thrown at us.
Okay. And in an agile environment that has multiple data modelers, how do they work together on the models?
Yeah, I mean, I think I come back to the very simple thing that's where Erwin Mart Server plays a very valuable part in it. If you use the Erwin Mart Server, you can have multiple modelers opening the same model, doing updates to it. People can work, and whether they're in the same sprint or not, or whatever, they can all work on the same models at the same time quite effectively. So you can have multiple people working collaboratively in the data modeling world by using Erwin Data Modeler, Erwin Mart Server. So I think Erwin Mart Server is a key function that really holds together the capability of Agile data modeling.
Fantastic. Well, on that note, I'd like to thank you again very much. If you wouldn't mind moving to your last slide. Just want to give a little shout out to one more session that's happening, Why Conceptual Data Modeling Matters. It's going to be a great use case with National Student Clearinghouse, the CDO and another colleague at National Student Clearinghouse, and our partner at Agile will be presenting that one. It's a fantastic session, so we hope everyone will stick around for that. Look for Jeff in the environment. I'm sure he would love to network and meet with anyone who'd like to strike up a conversation in the networking lounge, or be sure to get over to the the exhibition hall, where we do have all the dedicated booths of our product lines, as well as a professional services booth and a booth dedicated to the IT Central Station reviews for unbiased customer reviews. So peer-to-peer, either use them to see what others are saying, or if you are an existing Erwin customer, we'd love for you to consider doing a review yourself. They do all the heavy lifting. You just need to schedule an appointment and they'll pull it all out of you and then ask you all the right questions. So at this time, Jeff, thank you again for all of your efforts, and presentation was wonderful. We really appreciate it for you supporting Erwin Insights.